Okay, so in 8.1 we're going to be talking about inverse variation. We talked a little bit about direct variation last chapter, so that's going to come back into play. So first off, inverse variation, our main equation that we're building all of this off of is this x times y equals k. The other two equations are basically if you solve for y or solve for x. So this is how we're going to be writing our equations whenever it's asking for a formula or an equation to have it written in. This is how we're going to be solving a lot of them. Okay, we also have direct variation, which is the inverse of the inverse equation, which sounds a little confusing. Just think of it as they're inverses of each other. Okay, so this was a lot like when we were doing the y equals mx plus b. Okay, m and k represented our slope or our change that we were having in that situation. So it's going to be very, very similar to what we're doing because we're going to have to find slope to find that k in these ones. Okay, so my first one, when we're doing inverse variation, so if I were to graph it, remember you go left or right and then up or down. So I go right 2, up 15. So about right there. My next one, I go right 4, up 7.5. And the next one, I go right 10, up 3. Okay, and then my last one, I go right 15, up 2. Okay, so it looks kind of like this. Okay, the way that we're going to solve these, since the equation was y times x equals k, I want to figure out that equation for the graph there. So what we do is we do our y times x, so 2 times 15 gets me 30. 4 times 7.5 gets me 30, 10 times 3 gets me 30, okay? So you can see that that constant is 30 here. So if I were to plug in that constant, it would look like this. But whenever we look at our equations, we look at them as y equals mx plus b. So I get that x over by dividing it. So here is the main equation that I want to see when we're talking about inverse variation. Okay, so you're always going to do this y times x first to see if you can do an inverse, or our next option is going to be this direct variation. So 3 times 15 gets me 45. This gets me 320. So you can automatically see that that's not a constant. So my next check is this direct variation. So direct variation, we need to find the slope. So first off, I'm going to pick 2 points. So 315 and 840. Okay, slope, remember, is y2 minus y1 over x2 minus x1. This is how we're going to find our k in this one. Okay, so if I labeled x1, y1, x2, y2, I get 40 minus 15 over 8 minus 3, okay, which is 5. So the slope for that one is 5. So now let's check the bottom two here. So 10, 50, and 22, 110. So this one I would do 110 minus 50 over 22 minus 10, okay, which is also 5. So the way that we would write this equation is y equals 5 times x. It's kind of like our slope here that's going in for the k, that change. Okay, so is the relationship direct variation, inverse, or neither? So direct, remember, was that y equals kx, so we found the slope. Direct variation was y times x equals k. So first off, we multiply them and see if we get that inverse variation. So 2.2 times 8 gets me 1.6. 0.5 times 20 gets me 10, so I can automatically knock out inverse, and we check our slopes to see if it's a direct. So 0.28 and 0.520. So when I do it, I do 20 minus 8 over 0.5 minus 0.2, which is 40. Now let's check our bottom here. So 1.0, 40, and 1.5, 60. So 60 minus 40 over 1.5 minus 1.0, okay, which is also 40. So this one is y equals 40x, and that is going to be your direct variation. Okay, my next one, let's go ahead and multiply. So 0.2 times 40 gets me 8. 0.5 times 16 gets me 8. 8 and then 8. So this one I know is an inverse. And remember, it's y times x equals that k value we found. So if we divide both sides by x, it is going to be 8 over x. So inverse variation, and then there's your equation for it. So my last one is most likely going to be neither. So 0.5 times 40, this gets me 20. 1.2 times 12 gets me 14.4. So the next check is the slopes, so 0.540 and 1.212. So 12 minus 40 over 1.2 minus 0.5. So that is negative 40. Now let's check our bottom set. So 210 and 2.56. So 6 minus 10 over 2.5 minus 2. Okay, which is negative 8. So because it didn't match, this one is the neither. Okay, so you're figuring out the same thing again. So first off, let's multiply. So 3 times 15. We actually did this one right here. So it's the exact same one, so it's going to be the direct variation. So I'm going to skip ahead to this one. So 3 times 15, this gets me 45. 5 times 8.4 gets me 42. This gets me 42 and 45. So I need to check the slopes. So my first one I do 3, 15, and 5, 8.5, or 8.4. So 8.4 minus 15 over 5 minus 3. So that's negative 3.3. Now let's check 7, 6, and 10.54. So 4 minus 6 over 10.5 minus 7, which is negative 0.57. So this one is the neither. Okay, we got our last one here. 0.1 times 3 gets me 0.3. This one's 0.3, 0.3, 0.3. So this one we got the inverse variation. So y equals 0.3 over x as our equation. Okay, joint variation. So now we're going to throw you some words. You're going to have to make the equations instead of going off of a table. Joint variation basically means we're adding more quantities into it, okay? Jointly a lot of the times is going to be meaning multiplying. Anytime you see the word inversely sitting in front of something, that means what's after it is most likely going to be divided, okay? In all of these situations, there will always be that k constant, and it will always be on top or in front of your equations, okay? So if you look at the first one, we said jointly, which is why k, x, and y are being multiplied. Okay, my next one, it's jointly with x and y. This inversely is where that division happens, so that's why the w's on the bottom. The next one, it says z varies directly with x. Okay, inversely, so there's the division happening with the product of wy, which is why wy is on the bottom. So just remembering that inversely is that division that happens. Okay, suppose x and y vary inversely. Okay, so this is our general inverse equation was that y times x equals k. So when we do these, I have my given x and y. I'm trying to find the function. So I'm trying to solve for k. So what I need to do is plug it in first, because we're trying to find that type of slope here. So k is going to be 48. So to find the equation, all we do is plug it back in. So y times x equals 48. But when we write it, remember the x is on the other side. Okay, the reason that we're finding this equation is because I'm trying to figure out, hey, what's the equation if I want to pick another set that's going to vary inversely? So another set of x's and y's that I could plug in with that same constant, that same k, which I'm going to be doing in a minute. Okay, so my next one, we have 8 and negative 7. So that's negative 56. So I rewrite it in my equation. So y equals negative 56 over x. Okay, finding the equation that if I need to find another variable, I have found that k constant in the equation for it. Okay, I talked about joint variation before. Here it is again, because I'm going to start throwing z's at you. So when one quantity varies directly with two or more quantities, so just adding more variables into it. So y varies inversely with x. Okay, so we didn't say anything about a z in this, so we're still going to do that. Y times x equals k. So here's my initial given mount, and then I'm going to plug this in at the end. Whatever the find is, that always is last, no matter where it is in your problem. That find with whatever it's attached to is going to be your last step. So first off, let's plug in our given information. So 15 times negative 4 to find that constant. So 15 times negative 4, we got negative 60. We rewrite our equation, so y equals negative 16 over x. And now we put this in. We put our x in so that we can find out what our y is using that same constant. So y equals negative 60 divided by 10. So y represents negative 6. That follows suit with that same constant k. Okay, this one we got a z in it, so if z varies jointly with x and inversely, there's the division with y, and x equals 12, y equals 2, and z equals 18, here's my last step, that find. Okay, so first off, let's write our equation. It's going to be equal to the z. Okay, whatever's first is a lot of times going to be on that side of the equal sign. K is going to be on top. X is going to be on top with it because it inversely happens after it, so the y will be on the bottom because inversely, remember, is that fraction. Let's go ahead and plug in that given information here. So 18 equals k times 12 divided by 2, because we got to find that k to find the equation. So when I'm trying to find that other variable, it's represented by the same k value. So what I like to do is 12 divided by 2, which will be 6. To get rid of that 6, we're going to divide. So k equals 3. We rewrite our equation, so z equals 3x over y. My last step, use this information with the find in it. So z is the thing that's missing. I got 3 times 7 over 6. So 21 over 6 is what that z value is.